15 biggest dinosaur mysteries that have never been solved. Which was the first dinosaur? We know that there were over 300 species of dinosaurs and that these enormous animals showed up over 230 million years ago. What we don't know, however, is which one came first. That's because we currently only have bits and pieces of the fossil record. In the 1930s, the bones of a creature named Dinosaurus barringtoni were discovered in Tanzania. It was only recently studied in detail, though, and found to be older than the oldest known dinosaur. Dinosaurus barringtoni dates to about 240 million years old, but very little is known about it, including whether or not it was a true dinosaur, or just a close relative. The creature is an estimated 2 to 3 meters long, including its tail. It has the same bony crest along its upper arm that all known dinosaurs have. But further discoveries might lead to yet another change in what we know regarding the timeline of dinosaurs. 14. Were they warm or cold-blooded? Whether dinosaurs were warm or cold-blooded has been a huge debate for decades. There are certain things that give scientists clues, though, like growth patterns and bone microstructure. These clues suggest that dinosaurs were mesotherms, which means they relied on their muscles to warm their bodies, but their body temperature wasn't stable, unlike us. In other words, dinosaurs were somewhere in the middle. We could call them lukewarm-blooded. But the studies that came to these conclusions looked mainly at dinosaurs in warm climates. What about dinosaurs in cold climates? And what about baby dinosaurs? These are all things that researchers still need to look at and try to figure out. 13. Which was the biggest dinosaur? It's something we'd all like to know. Which was the biggest dinosaur of them all? You'd think that with a name like Supersaurus, we found the winner, but it's not that simple. Supersaurus is one of the biggest dinosaurs found. But there are other types of dinosaurs that are around the same size, about 100 to 110 feet. The problem is that the fossil record is incomplete, so most of the biggest dinosaurs are only known from bits and pieces of their skeletons, with the rest of their body being an estimate. Also, we could unearth a new dinosaur at any time, changing what we know and our perception of what the biggest one looks like. So, until we know for certain that we've dug up all the dinosaur fossils there are, and compared all the complete ones with each other, this one will remain a mystery. 12. How do they mate? Unfortunately, behaviors don't typically fossilize. Sometimes, bones can give us clues to an animal's lifestyle, though. For example, the type of teeth an animal has may indicate their diet. But their hunting or foraging behavior is usually just a guess. The same thing goes for mating behaviors of dinosaurs. We know that dinosaurs lay eggs. But we don't know what leads up to that point. Did the males fight each other off so that the winner gets the female? Did the males do mating calls or special displays to impress the females? These questions all still remain unanswered, and it's likely that they will always remain that way. We don't even know much about the sexual anatomy of dinosaurs. But it's believed that they were similar to birds in the sense that they may have had a cloaca, which is used for excretion and reproduction. 11. What was the function of their crests, spikes or horns? Many dinosaurs were adorned with crests or horns on their heads. One of the most recognizable dinosaurs with fancy headgear is Triceratops. Some dinosaurs even have plates and spikes, such as Stegosaurus. So, what was the purpose of these adornments? You might think that dinosaurs used their spikes and crests to fight off attackers, but paleontologists don't think so. Another possibility was that the spikes were important in temperature regulation. But studies have shown that their role in temperature regulation is passive and wasn't their primary function. Instead, paleontologists choose to look at the possible social functions of these features. Remember how we said that scientists haven't yet figured out how dinosaurs mated? Well, they actually do have some good guesses. One is that dinosaurs used their horns, crests and spikes to show off to potential partners. Others believe that they served as a way for dinosaurs to recognize members of their own species. Whatever the case, all we know is that these features make dinosaurs look so much more awesome. 10. How did they hunt? In Jurassic Park, raptors were seen hunting in packs. But a movie is just a movie. While we'd like to think that it was well researched and based completely on facts, it wasn't. Much of what we saw in the films was a product of the imagination, including the hunting behaviors of dinosaurs. Though some footprints have been preserved showing that different dinosaurs walked alongside one another, we don't know why they were doing this. Maybe they were hunting together, but we'll never know unless someone invents a time machine or finds a set of predatory dinosaur footprints crossing paths with a prey, both of which are highly unlikely. 9. How did they learn to fly? Many people would think that the closest living relatives of dinosaurs are the crocodiles, but they would be mistaken. It may come as a surprise that birds like the one you may have as a pet are actually the closest living relative of dinosaurs. You're probably wondering how that's possible, right? Like, how on earth could a giant T-Rex evolve into a tiny bird with feathers and the ability to fly? Well, T-Rex didn't evolve into birds. A group of smaller, feathered dinosaurs, called the Maniraptorans, did. These dinosaurs are thought to have started flapping on the ground, to catch their prey or to run up steep surfaces, and eventually began to fly. But the exact details of when and how dinosaurs learned to fly still remain a mystery that scientists are trying to figure out. 8. Which ones were fluffy? When you imagine dinosaurs, you think of huge, terrifying and scaly giants, not fluffy creatures. But some dinosaurs actually were fluffy. Of course, since we now know that birds are the closest living relatives of dinosaurs, it makes sense that the small dinosaurs that eventually evolved into birds also had feathers. The shocking thing is that even 30-foot tyrannosaurs have been found to have feather-like coatings. Pretty weird, huh? While we know that many different lineages of dinosaurs sported feathers, we don't know exactly which ones are yet to be discovered. We also don't know if the trait evolved multiple times or not. 7. Why were they so big? Part of what makes dinosaurs so fascinating, to both kids and adults, is their spectacular size. Some dinosaurs weighed over 50 tons. So, why were they so darn big? Well, there are several theories. One is that because of the higher temperatures of the prehistoric world, there was an abundance of vegetation. Dinosaurs were free to feast on as much vegetation as they wanted, so that's why they were so big. Of course, that theory sounds a bit odd. Think about it, the Earth was filled with microorganisms alone for millions of years, yet there were no giant bacteria running around. Other theories are that their size was a form of self-defense against other dinosaurs, or a byproduct of their cold-bloodedness. Of course, the answer may be a combination of some, or all, of these theories. 6. Which ones roamed at night? Dinosaurs' daily schedules aren't fossilized either, so we have to use the evidence left behind to try to piece together what their lives may have been like. Unfortunately, there's not much evidence. One clue that was left behind that may suggest that dinosaurs were active at night was a set of bones in their eyes called sclera rings. This structure may have played a role in letting light into dinosaurs' eyes at night. However, some scientists disagree, saying that sclera rings of animals active during the day are very similar to the ones in those active at night. 5. How smart were dinosaurs? Sure, some dinosaurs, like Stegosaurus, had relatively small brains. But they weren't all dumb. Since we can't go back in time and observe exactly how intelligent these creatures were, we have to rely on their encephalization quotient, EQ, which compares their brain size to their body size. Based on this, we can see that some dinosaurs, like Triceratops, are a 0.11 on the EQ scale, compared to humans who are a 5 on the scale. Other dinosaurs were almost as smart as modern-day wildebeests, according to the scale. But the question remains, could dinosaurs have evolved a human-sized brain if they lived a few million more years? 4. How fast could they run? Forget what you've seen in the movies. The big screen depictions of how fast dinosaurs ran are highly exaggerated. Dinosaurs were definitely limited by their size, body plan, and metabolism when it came to movement. Their gigantic size and short arms are indicators that they couldn't run very fast. Can you imagine a huge T-Rex tripping over a rock and trying to get back up with its tiny arms? Scientists can also look at dinosaur footprints to try to figure out the animal's speed. The only problem is that dinosaur footprints, and especially a set of tracks, are very rare to come across. The only other thing that they can use as a clue to dinosaur speed is modern animals. Based on this, it's assumed that large, carnivorous dinosaurs were slow at moving and ornithomimids with their long legs were probably the fastest. 3. How do they raise their young? One thing is for certain, different types of dinosaurs had different ways of raising their young. Unfortunately, we don't know exactly how each type of dinosaur raised their young because behaviors aren't fossilized. The only things we have to look at for answers are preserved nesting grounds and analogies with modern animals, especially birds. The fact that dinosaurs also laid eggs means that they likely gave birth to several newborns at a time. It's believed that Seismosaurus, for example, laid as many as 20 to 30 eggs at a time. Why so many? Well, the majority of their eggs would be eaten by other dinosaurs, unfortunately. So, they had to lay many to ensure that at least a few survived. In the 1970s, nesting grounds of Maiasaura were discovered. These revealed not only dinosaur eggs, but hatchlings, juveniles and adults, too. This implied that Maiasaura took care of their young until they were old enough to fend for themselves. But, not all dinosaurs were like this. Some dinosaurs, like the Apatosaurus, had a better chance at surviving on their own rather than getting crushed by its own mother. These dinosaurs are all plant-eating, though. Much less is known about the carnivorous dinosaurs, since they didn't lay as many eggs. It's assumed that these dinosaurs laid their eggs then left them alone, but that's only a guess. 2. Did they have predators? The predator-prey relationships of most dinosaurs remain unknown, since we only have the fossil record to go off of. We have a few clues as to what dinosaurs ate, thanks to some fossilized stomach contents that have been found. For example, Baryonyx's stomach was found to contain fish scales. But this is just one type of dinosaur and the stomach contents only show its last meal. Surely, they ate different things. On the other hand, finding a dinosaur's predators is a bit more of a challenge. However, finding two fossilized dinosaurs that died while fighting each other may provide us with some answers. For example, a Velociraptor and Protoceratops were found together in Mongolia, each bearing teeth marks in their bones. This shows that they perhaps preyed on one another. But again, this is just one example and there were hundreds of different kinds of dinosaurs. 1. What color were they? Dinosaurs are often depicted in drawings and movies as being green or brown, but those details are just a product of the imagination. For a long time, people have guessed what color dinosaurs were by using today's reptiles as a guide. But there may also be another way of finding out the color of dinosaurs. In 2008, researchers using a scanning electron microscope discovered melanosomes, pigment-bearing organelles, in a 100-million-year-old feather. This proved that the color of feathered dinosaurs could survive fossilization. Indeed, in 2010, this is exactly what was discovered in fossilized dinosaurs found in China. However, scientists must be careful when studying these because the color pigments may have degraded over time, and the animal may have changed colors after death. Also, while melanosomes are responsible for some feather colors, they're not responsible for all. Diet plays a large role, too. Regardless, scientists still have a lot of work to do when it comes to figuring out the colors of all the feathered dinosaurs and also searching for melanosomes in the skin of non-feathered dinosaurs.